All right, and now we're back with day 3, negative exponents. So, really, the essential question for today is super straightforward. It is, what do negative exponents mean? So, really, what are they? And that's what we're going to be delving deeper today into and finding out. That was the most awkward sentence ever, but I'm not going to edit the video. Yes, we're going to be delving deeper and into to find out what negative exponents means. So, to do this, let's take a look at a pattern. We know that 10 to the third is 1 followed by the 3 zeros. We know that 10 squared is 1 followed by 2 zeros, and 10 to the first power is 10 followed by 1 0. See, exponent 1, 1 0, exponents 2, 2 zeros, exponents 3, 3 zeros. All right. But we further see that there's a pattern. In the standard form table, we see that 1,000 divided by 10 gets you to 100. 100 divided by 10 gets you 10. So a lot of people instantaneously, they go 10 to the 0 is 0. Wrong answer. Not happening. That is not the right answer. So really, to find out what that is to find and continue that pattern, which is just dividing by 10. So 10 divided by 10 gives us 10 to the 0 power, which is, it is 1. So to continue this pattern, I take 1 and divide it by 10, and that makes a fraction. Notice 10, 1 with 1 0, now in the denominator. Which means if I divide it again, I have 10 to the negative 2 power, to 10 to the negative 2, and that's really going to give me 1 over 10 to the second power. Notice the negative exponent is just changing from a numerator to a denominator. If we see the pattern continuing, 10 to the first, 10 to the second, and now 10 to the negative 3 will be, you guessed it, you are correct, we're dividing by 10, and it is 1 over 10 to the third power. And again, this is 10 to the negative third is in the numerator, and then when I take that negative exponent away, it changes location into the denominator. So negative exponents are just changing location. All right, so let's take a look at another table and another pattern. And here we have the 2's. So if I take a look at the 2's, 2 to the third power is 8. Divide 8 by 2. You get 2 to the second power, which is 4. Divide that by 2. You get 2 to the first power, which is 2. Of course, continue the pattern. So 2 divided by 2 is 1. Yes, 2 to the 0 is 1. 10 to the 0 is 1. I see another pattern forming. More on this later. So if I take 1 and divide it by 2, of course I end up with a fraction, 1/2. And 2 to the negative second power, really all I'm doing is dividing by 2. So I have 2 2's in the denominator, which gives me 2 squared. Just like over here, I had 3 10's in the denominator, so it gave me 3 10's, 10 to the third. Here I have 2 to the negative third power. Of course, that gets me another dividing by 2. So if I divide again, that gives me 3 2's in the denominator, or 2 to the 2 to the third power. Again, this pattern, negative exponents are just changing location. So negative exponents have 2 rules. Again, I'm going to say this over and over. Negative exponents are just changing a location. See, like 10 to the negative third is equal to 10 to the third power. 1 over 10 to the third power. Sorry, 1 over 10 to the third power. All right, and then any number raised to the 0 power equals 1. And see, I'm going to rewind a little bit here, and you're going to see back here, I remember I told you 10 to the 0 is equal to 1, 2 to the 0 is equal to 1. That means that you can start seeing a pattern. And since math is all about patterns, we know that any number raised to the 0 power is equal to 1. Negative 12 to the 0 power, 1. 7 over 15 to the 0 power, uno. Pi to the 0 power, in Korean now, hana. It's all just 1. It's super duper simple. Anything to the 0 power is going to equal 1. Skadoosh. 2 rules for negative exponents. All right. Let's get some practice. If this is if you're watching this video at home, or if you're watching this in the classroom, I'm definitely going to pause. You have all of these problems. Start it when you're ready to check. But first, let's pause. And we're back. Did you get 6 to the third, 1 over 6 to the third, or 1 over 216 if you multiplied? Heck yeah. 1 over 8 to the fifth, 1 over 7 squared. These are the easy guys. B to the negative 8, because see, I'm changing it back. It was already positive, so I'm changing it back into a negative. That brings us to E. What the heck, man? Both of these are negative. Now, remember that negative exponents are just changing location. They just change the location. So if I'm really looking at it, for E, the x will go into the denominator, the y will go into the numerator. Kapow. They just trade places. They're changing location from numerator to denominator and denominator to numerator. And that gives f, like it makes f really simple. We just flip it, and then the negative exponents will go away. And 4 squared is 16, and 3 squared is 27. Check your work there, people. Make sure that you understand that, remember, negative exponents is just changing a location. Here's some more practice. I'm going to just ask you to pause the video again. I've got G, H, I, and J if you're doing this at home or if you're doing this in the classroom. So let's pause. And we're back. So I've got all of these. We're just going to check our work real quick. Same principle, guys. This was even easier than before. It's not difficult. I'm never going to really ask you guys to kind of like multiply it out unless I'm raising if I'm raising a product to a negative exponent power. But this is just giving you an idea. 6 to the 8th is 1,679,616. And again, here I have negative 3 times itself 5 times, so it's negative 243. S to the negative 9 is equal to 1 over S to the 9. That is not a 5, which is why I don't have a number. And then t to the negative 11 is just 1 over t to the 11th. It's really straightforward. Ladies and gentlemen, this really wasn't all that hard. If you're writing in the classroom, write your summary. Make sure your table of contents are updated. If you're at home and you're just watching this video for review, make sure those things are already done. If you're just checking me out on YouTube, then hey, if you want to do this, I'm not gonna say no. It always helps your learning. All right, guys. Until next time, that was negative exponents with me, Mr. Hain.